Think and Solve. This is Chapter 6, Think and Solve. Number 30. Joanne drives her car with a mass of 1,000 kilograms at a speed of 20 meters per second. Show that to bring her car to a halt in 10 seconds, the road friction must exert a force of 2,000 newtons on the car. All right, so we have an initial momentum of 1,000 kilograms times 20 meters per second. At least that's a magnitude of momentum. Or 20,000, I'll just say units of momentum. If it's coming to a halt, that means that the change in momentum is 0 minus 20,000, or negative 20,000 kilogram meters per second. That is happening over 10 seconds. And so the impulse, which is equal to the change in momentum, so you have force times time is equal to change in momentum. You have 2,000, that's the new dog right there. So we have 2,000 newtons times time, which is 10 seconds, is equal to 20,000, divide by 10. And so you have 2,000 newtons of force, basically 20,000 divided by 10. Number 35, a 5 kilogram fish swimming at 1 meter per second swallows an absent-minded 1 kilogram fish swimming towards it at a speed that brings both fish to an immediate halt. So conservation of momentum, it's a perfectly inelastic collision. And so if the final momentum is 0, because they stop, so basically they're coming along and it eats it. So if it stops, the total momentum final is 0, which means the total initial momentum must also be 0. So if one has an initial momentum of 5 kilogram meters per second, because 5 kilograms times 1 meter per second, the other one must have a total momentum of negative 5 kilogram meters per second. And since it has a mass of 1 kilogram, its velocity must be 5 meters per second. So basically you have one going this way at 5 kilograms times 1 meter per second, and the one going this way, 1 kilogram times 5 meters per second. They're in opposite directions, and so since they're vectors, when you add, they cancel each other out. Number 37, 2 automobiles, each of mass 1,000 kilograms, are moving at the same speed, 20 meters per second. They collide and stick together. In what direction and at what speed does the wreckage move? Now, if one's driving north and one's driving south, when they connect and collide, well, the total momentum is 0 to start with, because I have 1,000 times 20, or 20,000 kilogram meters per second this way, 20,000 kilogram meters per second that way. Total momentum is 0. One's positive, one's negative. You add them together, you get 0. Part B is the trickier one. And I've shown in figure 6.18, which is page 102, the previous page. So you have one driving north and one driving east. So from my point of view, traditionally east that way, north that way. And I'm not quite sure if you're seeing that backwards from what I'm showing. And so when they are meeting, I've got 20,000 units this way, 20,000 units that way. When they combine, it must have 20,000 newtons, 20,000 kilogram meters per second one way, 20,000 kilogram meters per second the other way. We got to do Pythagorean theorem. He's asking for the speed. So if I have 20,000 one way, 20,000 another way, and they combine, so my total mass is 2,000. I divide my 20,000 and my 20,000 by 2,000, and I get 10 meters per second by 10 meters per second in perpendicular directions. And so add head to tail, whichever way you want to do it, and you would basically have a triangle, so Pythagorean theorem. So it'd be 10 squared plus 10 squared equals the speed squared, which is 10 times square root of 2, or around 14.1 meters per second. And the direction, now there's no preference for one or the other. They're both traveling equal momentum in this direction, so when they combine, it's going to have to be at a 45-degree angle, so they'll have to be moving northeast, because there's no domination of one over the other. And that is it for the Think and Solve from Chapter 6.